All right, Algebra 1B students, welcome to part 1 of section 11.2, and today we will be multiplying two rational expressions together and then simplifying if we can. Okay? Now, just like when we multiply fractions, we can multiply rational expressions. Remember that rational expressions just means some sort of equation on the top and bottom of a fraction bar, like 3x minus 6 and x minus 2. So when we multiply two rational expressions together, it is just like multiplying fractions. And to multiply fractions, remember we just multiply the two numerators together, meaning multiply the top of this one times the top of that one, and multiply the two denominators together. The tops and the bottoms get multiplied together if we want to multiply two rational expressions. So for our purposes today, the tops and the bottoms basically just become more factors that we can cancel out from top to bottom and so on and simplify. We still also need to be on the lookout for excluded values. Values that x is not allowed to be. So we will start right here. What is the product, and state any excluded values. Now, I think it is more helpful when you see two rational expressions being multiplied to do the excluded values first. Okay, before you multiply the two denominators together, just list out all of the excluded values for each of those, and those will be the excluded values for the whole thing, for the product, when you get done multiplying. So, if I look here at 6 over a squared times negative 2 over a to the third, and I want to list the excluded values, I have to think of how could I turn one of these two denominators into 0? Well, if a squared is equal to 0, and I square root both sides, the square root of 0 is just 0, so a would have to be 0. Right? Obviously, if I'm going to have a squared be 0, then a needs to be 0, because any other number will multiply by itself and not be 0. The same is actually true for a to the third. If a to the third is 0, well then a has to be 0, because any other number times by itself 3 times will never get multiplied by 0, so it won't be 0. So anytime you just have an a to any power equal to 0, you know the excluded value is a 0 or equals 0. So what I know already is based on these, if I put these two things here together, I know that a, in this case, cannot equal 0. Now it's very possible that we might have different values, so we would have to list both if these two were different values, but in this case they're not. They're both 0, so a can't be 0. There's my excluded value. Now I need to find the product, meaning multiply these two things together. So across the top, I have 6 times negative 2. 6 times negative 2. And on the bottom, I have a squared times a to the third. Okay? There's no parentheses or anything that I need to worry about here. I will have to worry about that later, but not right now. So I can put these together because there's no parentheses anywhere, nothing added or subtracted. It's all multiplying. I can go ahead and say negative 12 over a to the fifth, because remember from chapter 7 we want to add those two exponents when they have the same base. So my simplified version is here. I've already taken care of my excluded values before I started. So it is negative 12 over a to the fifth. A cannot equal 0. Okay. Now, if we look at this product here, letter B, I have 4 pieces here, obviously a numerator and denominator for each fraction, and 3 of them are x plus something or x minus something. Okay, so we need to think, whenever we see a plus sign or a minus sign, like x minus 2 or x plus 1, think of it as being in parentheses. Okay? Think of it as being in parentheses. So that when I multiply them together, I will leave them in parentheses, and I'll explain why in just a minute. But first, I'm going to deal with my excluded values here. Okay? Because I have two denominators, and it's quite easy to see what will make them 0 or what they are not allowed to be. First of all, on the left-hand fraction, my denominator is x minus 2. So if I want that to be 0, x must equal 2. So obviously x cannot be 2 here. And the same thing is true when I see that x minus 3 is 0. Well, that means x must be 3 to make that true. So I know that x cannot be equal to 2, and x cannot be equal to 3. Those are my two excluded values. Okay, so I know that right away. X cannot be 2, and x cannot be 3. Now I can multiply these two things together. And so I will do that by saying this is on the top of the fraction, going that way, x times x plus 1. And on the bottom, x minus 2 times x minus 3. Now, we certainly could distribute on the top, do the distributive property with the x. We certainly could FOIL on the bottom and get an x squared quadratic equation. But we're not going to do that because we want to be able to see very quickly that there is nothing that I can cancel from the top and bottom of this fraction. So I am not going to distribute or FOIL or do anything here. I'm going to put my pieces together, list out all of my factors that I'm seeing here, and then decide, is there something that I can cancel from the top and the bottom? Well, in this case, I have an x and an x plus 1 on the top. I have an x minus 2 and an x minus 3 on the bottom. None of those are the same, so there is nothing that I can cancel, no set of parentheses on the bottom that I can cancel from the top. So I am done. So all I'm really doing here is squishing this together into one fraction and leaving the pieces separate so that I can see very quickly if I can factor something out or not in this case. Okay? So my simplified form, my product, I shouldn't say simplified form, my product is here. My excluded values are there. So x times x plus 1 over x minus 2 times x minus 3. X cannot be 2, x cannot be 3. Okay. Now obviously, at certain points, we might have to do some factoring and canceling when we find one of these products. Okay? So here, this problem is asking us to find the product of x plus 5 over 7x minus 21 times 14x over x squared plus 3x minus 10. Okay? So the first thing that I am going to do is factor everything that I see that I can. Now both of the numerators, x plus 5 and 14x, I don't see anything in there that I can factor out of each piece there. So I'm just going to leave those alone. But both denominators I can factor. So this first fraction here is going to become x plus 5 on the top. As I mentioned, we can't factor that because it's just a single x and a single number. But the bottom I can factor out a 7 and leave an x and a minus 3 if I divide 21 by 7. And then over on the other fraction, 14x is just itself on the top, but the bottom can be factored. And I'm looking here, this is a quadratic, so I'll factor like this. I'm looking for two numbers that multiply to be negative 10 and add up to be positive 3. Well, I could multiply to get 10 if I did 5 and 2, and because the 3 is positive, I will make the 5 positive, the bigger number positive, and x minus 2. Okay, so I've now factored the denominators here, which makes finding my excluded values very, very simple. Very, very simple. So in this case, my excluded values are anything that makes either one of these denominators 0. So I'm looking here, I'm looking here, and I'm looking here. Well, the number that would make this factor here 0 is a 3. This factor here, a -5, would make that 0, and here a 2. So there's my 3 excluded values. So I know right away x cannot equal 3. X cannot equal -5. X cannot equal 2. Those are my excluded values. Okay? I want to do my excluded values first because now I can cancel things from the top and the bottom. And make my life a lot simpler because I see on the top of the fraction on the left an x plus 5 and the bottom of the fraction on the right an x plus 5. So when I squish all of these things together, my x plus 5, because of that plus sign, I'm going to put it in parentheses, and I'm going to end up at x plus 5 times 14x. And on the bottom, I'm going to end up with a 7, and then in parentheses, x minus 3, x plus 5, x minus 2. Okay, so now I have squished this into one fraction, and I can start canceling things. I'm going to cancel this x plus 5 with this x plus 5, so those are gone. And I also see a 14 on the top of the fraction and a 7 on the bottom. I can cancel those as well. The 7 gets canceled, the 14 actually becomes a 2. So now, on the top, I only have a 2x left. The bottom, I have x minus 3 in parentheses and x minus 2 in parentheses. This is my product. Now notice again, I am not going to FOIL the bottom so that I can see quickly that there's nothing else to cancel. But this is my product. These are my excluded values. So 2x over x minus 3x minus 2, x cannot be 3, x cannot be 2, x cannot be -5. Okay, so be aware that we're going to have to start putting some of our tools together. Factoring, canceling, multiplying, cross, and finding excluded values. But, once again, please make sure you find excluded values before you cancel anything. Okay? Please make sure you find excluded values before you cancel. One more thing that I want to look at, not very difficult at all, but be aware that not everything has to look like a fraction right away. Okay, you could be asked to find this product here. What is the product of 2m plus 5 over 3m minus 6 multiplied by m squared plus m minus 6? So in this case, I have one rational expression here, and this one is not a rational expression. It's not a rational expression, but I can turn it into one by doing something very, very simple. Putting a fraction bar underneath all of that and putting a 1. Okay? Now, this is a rational expression because I put it over 1. Now this is a fraction of polynomials, and this one is as well. So now we can follow our rules and find the product here. Okay? So the only thing that we have to be careful of is multiplying this 3m minus 6 by the 1 because that's the denominator of our other expression. Okay? And then we will multiply the tops, of course, there. Now the first thing that I will do is factor everything that I think I can. I don't think I can factor the top on the left. That's just 2m plus 5. Because 2 and 5 can't get pulled out together. The bottom, however, is 3 times m minus 2. I can pull a 3 out of those two pieces. And then here in my polynomial, I am looking for two numbers that multiply to be -6 and add up to be +1. Well, 6 is 3 times 2, and I will make the 3 positive so that my m becomes positive. So now this says m plus 3, m minus 2. And the bottom, timesing by 1 will not change anything, so I'll just leave the bottom alone. Now please notice that I've already squished this into one fraction. I've already done the multiplying together. That's perfectly okay. If you have two fractions multiplied, you can just squish them together into one, as long as everything stays multiplication. Now from here, all I can do is cancel the m minus 2. So those are gone. And my product, now I'll put the 2m plus 5 in parentheses because of that plus 5 there. That's one piece. The other piece left on the top is m plus 3, and the only thing left on the bottom is 3. Okay, so here is my simplified form. There's my simplified form. Okay. In your practice problems, if the problem does not say to state excluded values right there, then you do not have to state your excluded values. You don't have to worry about it. Okay? If the problem does not say state excluded values, you do not have to state the excluded values. Okay? But if it says to state them, please make sure you state them, and I think it's easiest to start with the excluded values. Okay? Now, I got one problem for you to try, and that'll be it. This should put everything together, I hope. This is just asking what the product is. I am not asking you to state the excluded values. Just find me the product. So pause the video, take a look at this problem, and come on back, and I'll show you what we should get. All right, obviously here we need to start by putting this over 1 so that we have two rational expressions. Then I'll factor everything on the left. The top is 2x minus 7. The bottom is 2x minus 3. You can pull a 2 out of those. And then I will just squish the whole fraction together. And this is not one that I can factor super easily without using a box and diamond problem, which I will not ask you to do. So at this point, I can cancel these 2's, and doesn't look like I can cancel anything else. So my product here is this. If we did factor this with a box and diamond problem, then I'm sure that we could cancel out the 2x minus 3 on the bottom, but like I said, I will not ask you to do that. So this would be a perfectly acceptable answer for me as long as you cancel those 2's in front, and then there's the rest. So if you have any questions about factoring and canceling, what I'm asking you to do, what I'm not asking you to do, or anything dealing with multiplying rational expressions, please make note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.